Okay, we're going to do another series of Night Solves Chem. This is on standard heat. I look a little diagonal. Am I diagonal? I think that's better. All right. Night Solves Chem, thermo problem solving, standard heat of formation. That's where we're going next. So take a look, and here we go. Okay, it didn't stop. Good. So standard heat of formation is delta H with the degree symbol up top. I don't know necessarily what that's going to look like pronouncing it, but standard heat, standard, and not would be standard heat delta H or enthalpy. We're going to take it, its general format is it equals the standard heat of formation, which is a value from a data table. Data table, like this. These are data tables. We're looking at this data table of standard heat. This is a typical textbook standard heat data table. Notice standard heat, delta H, standard F, kilojoules per mole of various substances. Okay, so once again, delta H standard F of products minus delta H standard F of reactants. So delta H standard means standard heat of a reaction or enthalpy. The standard is based on a series of conditions. Those conditions are standard temperature and pressure. Standard temperature in physics or physical constant is 25 degrees C, 1 atmosphere. That information is mainly just pointing out stuff. It's useless as far as what we need to do for problem solving. So it just stands for STP. That equals the addition of all the products, delta HF values from the data table. Look those up, all the delta HF values for all the products, add them together, and then do the same thing for reactants. Addition of all the reaction delta HF values, add them all up for the reactants using the data table. Then from the provided table of values, we're going to subtract the products minus the reactants, and that's how you get your standard heat. At this point, you could probably pause the video and go try it on your own. But just in case, I'm going to finish this video. I'm going to do a practice problem, and we're going to see how this goes. Let me grab the pen real quick. I'm going to watch this in action. Just for one more time for those listening at home, with their dog, check it out. Standard heat equals standard heat of formation of all the products added up, standard heat minus standard heat of all the reactants added up. Let's do it and go forth. Here we're going to calculate the delta H for the following reaction. We have 8 aluminums. Now we do have to multiply by the coefficients because the coefficient is present. The standard heat applies to aluminum. When we have 8 of them, it needs to be 8 aluminums, just for the record. All right, since our standard reaction is delta H standard equals, oops, that's a 0. Delta HF of the products, not big F, of the products minus delta HF of the reactants. There's a mathematical symbol that represents addition of things. Reactants. And that is this symbol, the sigma symbol. I'm not going to use it for our purposes, but essentially it just means to add up all the things. Let's add up all the products first. Al2O3. Let's look at our data table. In the aluminum, Al2O3 has a delta HF value of negative 1669.8. And there are, 4 of them. So 4 times negative 1669.8 plus, because we're going to add up all the products, 9 FEs. Where does Fe come from? Fe is iron. It's a solid. That's what we're looking at over here. The delta HF for Fe as a solid is 0. That's helpful. Oops, wrong way. Again. So that's 0 for the times 9, just to be consistent here. 0 times 9, because that's the Fe, the standard heat of Fe, minus all of the heats of reactants. So that's 8 ALs. Aluminum is also 0. 8 times 0 should be easy. 8 times 0 plus the other reactant, Fe3O4. That's an iron molecule right here. Fe3O4. So negative 1117.1. So 1,000 that is. So that is 3 of them. 3 times negative 1117.1 kilojoules per mole. And we go from there. Sounds pretty easy, self-explanatory. You finish doing your math here. you get, let's just do it real quick. Okay. And the final answer we get is negative 3327.9 kilojoules per mole. By the way, if you didn't want to hear that, go back, rewind real quick, pause, and try it on your own. Once again, that's negative 3327.9 kilojoules per mole. We got that from a certain reference place, and it gave the answer as negative 3316.5. So their data table must be slightly different. Ours is relatively updated, so I'm going to trust it pretty strong right now, although those heats can vary just slightly. Anyway, we're talking about tens out of kilojoules per mole. Very minimal, same value. They may have gotten some numbers that were rounded differently or whatnot. Nevertheless, that's us. Negative 1669.8. I can check my numbers. Negative 1117.1 times 3. My calculator's trustworthy. I can trust it to work it out. In case if you got your numbers a little bit different, you might see a different value. Anyway, that's standard heat of formation.